Hey guys, hopefully this is working now. Yeah, we got it. All right. So, yeah, how are you guys doing? This time you actually can respond because we have chat now. So that's fun. Give me a second to pull up my trusty setup, as in opening YouTube on my phone, and then we'll be good. Okay, so here's the plan for how I'm going to do this round. First, I'm going to just look at the div2 problems and solve from them what I can, and then after that, I'm going to do a virtual of the div one. So I'll end up covering as many problems as I can, but still like do the virtual thing that I advertised. Actually, I want to see how this is working first. Does this just like exist? I've never seen this before. I guess it is though. But if you want chat, unfortunately, you'll have to just like exist. You'll have to like not be on Codeforces because apparently it doesn't work. Okay. Anyway, yeah. So the overlap between the two divisions is just the first two problems, right? Like division and okay. So these are the first two, and I'll do these first. Say my name, please. Hi, Crystal Violet. How are you doing? No Twitch because YouTube is easier, in my opinion, especially for just Codeforces. I'll figure out Twitch later, just like not right now. Okay, so we're starting with this. Again, I'm doing the first two div problems first. I'm doing the first two div2 problems first. So you're given two arrays A and B, each consisting of n positive integers and integer x. Please determine if one can rearrange the elements of B such that AI plus BI is less than or equal to x holds for each I. Okay. Well, this is like, I'm pretty sure this is well known. Consider the two arrays like so. For example, 1, 2, 3, 4, and the other array is also 1, 2, 3, 4. Now we want to kind of match these blue elements to the red elements. You're probably right. I can't say your name correctly. Probably can't. Sorry. But like, okay, this is the minimal number, right? So if the maximum number and the minimum number are already greater than x, then like there's nothing we can do. Because like what else are we going to pair this with? There's nothing else we can do. We have to pair this with something. And similarly, we have to pair the maximum number with something. So if we can't even pair the maximum number with the minimum number from this, then there's nothing we can pair this with to make it work. But if we can, then it like doesn't hurt to pair the maximum number with the minimum number, because like this, like the thing we want to use for this minimum number is the smallest. So if we can get the biggest out of the way now, then it'll help us in the future, right? So now we have this smaller subproblem, and we do the exact same thing. We pair the current minimum with the current maximum, and essentially the way this works is you can implement this simply by sorting the first array and reverse sorting the second array. And then you check all of these pairs individually, and if they're all satisfying the condition, then you're good. Otherwise, it's not possible. So let's just do that. And B. Right, okay. Now, whoa, what was that? Okay, ignore that. I think my lights just flickered somehow. That's fun. So we'll check each element. If any of them make it impossible, then it's impossible. And yeah, that's just it. Oh wait, do they have oh, the arrays are already sorted? Okay, whatever. I'll just sort them again. Doesn't really matter that much. Yes, yes, no, no. Which character can be printed in any case? Sure. Alright, that was A. So essentially, because the arrays are already sorted, you just reverse the second array and then be done. Okay, 3025, interesting number. So this is B. There's a famous Olympiad which has more than 100 participants. It consists of 2 stages, the elimination stage and the final stage. At least 100 will advance to the final stage. Yeah. A result of the elimination stage is the total score in 2 contests, but unfortunately the jury lost the final standings and only has the standings for the first and second contest separately. Okay. They're ranked by their point score in non-increasing order. Wait. Okay. I should make sure I understand this. Yeah, I mean, like, O of n versus n log n, that's true. Like, you could just do the reversal and it'd be O of n, but, like, it doesn't really matter if you sort. The numbers are tiny anyway. I just realized I forgot about this tradition we have. So every time I do a video, I update my template to include my subscriber count, and the ultimate goal is that we're eventually going to get a memory limit exceeded verdict. And so, guys, I can feel this. We're actually like really close. We only need like 9 million more. So if you guys contribute now, we'll get there probably today. I don't know. We'll see how it goes. Anyway. That's just for fun. So in each contest, participants are ranked by their point score. When 2 participants have a tie, they're ranked by their passport number. What? Okay. First contest, participant on the 100th place scored 8 points. Jury checked all participants and found out they all have at least B points. 100th place has C points, and they all have at least D points in the first contest. To 2 contests, all participants are ranked by their total score in 2 contests in non-increasing order. When participants have the same total score, tie-breaking with passport numbers is used. The cutoff score... All participants are ranked by their total score in 2 contests in non-increasing order. What? This is slightly weird. Wait. Okay. What does this mean? I'm glad this was a div 2 problem and not a div 1. So for the first test case, there are 101 participants. Okay, sure. Each have 1 point for the first and 2 for the second. 50 participants with points 5 and 9. 50 participants with points 4 and 8, and 50 participants with points 2 and 9. So it's the smallest possible value of the cutoff score. So I'm assuming the cutoff score is at most 18. And, yeah, please don't spoil, by the way. I haven't seen anything, but still. So the cutoff score is at most 18. That's a thing. And maybe we can just, like, brute force this. This is weird. I'm seeing in the chat you guys are also confused by this. Yeah, this is kind of confusing. In each contest, the participants are ranked by their point score in non-increasing order. participant on the 100th place scored A points. Right, okay, let's draw this out. So you have this score A. And so obviously, this is contest 1. So obviously every person in this range of 1 to 100 scored at least A points, because that's just how the rank list works, right? It's the top, yeah. And then, so on the second contest, which I'm going to label as blue, everyone in the same range also scored at least B. And then on the third, okay. And on the third contest, everyone scored at least C. But these people could have been different, I guess. And then here everyone scored at least D. Jury checked all participants. Okay, so these are the colors. Wait, is it just, I have a stupid idea. Is it just this? No, it's not that. Wait, it's like some sort of like minimum thing going on. So like we want this to be as small as possible, right? So we want to give all these people the smallest score that we possibly can. And I think they're just construing this to confuse us. So let's just like ignore the sample explanations and try and do this ourselves. So we know that all these participants got at least, on this sample case, it's at least 11. Because this is 9 and this is 2. So we know all the participants here got at least 11. And we know all the participants here got at least A on the first contest, A on the first contest, and so they got at least this on this one, at least this on this one. So they got at least 12. So, right, like that's it. So we have 100 participants in which these 100 have to get at least 12. Because like that's the constraints of A and B. And we have a separate 100 participants that have to get at least 11. And in general, we have 100 participants that have to get at least A plus B, and another 100 that have to get at least C plus D. And so the way that works is basically we want to make the score as low as possible. So there's no reason to give these people extra points. And because we know that we're given that D is less than or equal to A and B is less than or equal to C, which means that like if we make this score any higher than D, if we make any overlap between these two groups, then it's going to make our answer worse. So the answer should just, I think it's just the minimum of these two. It's kind of a guess, but I kind of, like, it makes sense. So wait, let me see if that makes sense. So we know there are at least 100, so the statement says there are at least 100 participants that scored at least A on this and at least B on the second one. And there are possibly separate another 100 participants that scored at least D on the first and at least C on the second. So let's say these participants are disjoint, which means that there are a separate 100 participants here than the 100 participants here. Then, like, that's just better off. Because otherwise, if we have some participants that are in both of these groups, then that will just make their score higher. So why do that when we're trying to minimize the cutoff, right? So we'll assume these participants are disjoint. So now it's just the top 100 participants out of this group of 200, which is to say the 100 that have the higher score out of these two. So that essentially boils down to which of these two scores is higher. And that's just the maximum of the two. That is what I think it is. Maybe we'll get wrong answer. I don't know. That would be pretty funny. Okay. So that's the idea. The answer is this whole statement just basically tells you to print the maximum of A plus B and C plus D. Does that make sense? Oh yeah, the array in B is indeed non-increasing. That's true. Not necessarily sorted, or I mean, not necessarily increasing. Okay. Anyway, so those were the two div2 problems, I think. And now I'm going to virtual the div1. Although it's not really a serious virtual because I'm like streaming it anyway, so it doesn't matter that much. I'm doing the virtual more for the time limit than anything. Okay, so this is the plan. Are you all ready? I'm gonna cover the div1 problems now. Yeah, viewership is insane. Doing this Codeforces thing was a good idea. I should do this more often. Okay. I hate D's name already. God. Fun. When will I become an LGM? I don't expect that to be anytime soon. And when will I beat tourists? That's probably never. Oh, hi, Kostya. How are you doing? Did you win the round yet? Okay. T pairs of integers pi and qi. For each pair, decide to pair the greatest integer xi, such that pi is divisible by xi is not divisible by qi. Whoa. Wow, very close to IGM then. Congrats. Pi is divisible by xi is not divisible by qi. The greatest integer. So we can prime factorize qi, I guess. If we prime factorize qi, which we can do in like square it out or something, then we just need to like not have those prime factors, right? But it should be made of the prime factors of pi. The problem is pi is huge. qi is not huge, but pi is huge. So yeah, that's like slightly a problem. What do we do about pi being big? Because we also like can't even find the we also can't even find the factors of pi to like do anything about it. Oh wait, actually I have an idea. Okay, let's yeah, okay, I see. So take qi, right? Let's make it like 30, for example. Xi is not divisible by qi. Right, take qi, and then let's say it's divisible by, let's say qi is 30, which means its prime factorization is 2 to the 1, actually let's make it 60. So its prime factorization is 2 to the squared times 3 to the 1 times 5 to the 1, right? Now we want a number that's divisible by pi, or we want a number that divides pi, so let's just like start with pi. But then, do we need moderators? Wait, are people actually like spoiling? Come on. Okay, wait 1 second. Let me, there. Here, fix everything. So let's start with pi, because pi is obviously divisible by pi, right? But then, like, if this number is also divisible by qi, then we want to make it not so. So consider like all of these prime factors. If pi is, say, like 2 to the 3, 2 to the cube times some value x, where we don't really care about the value of x, then we want to make it so... How would this work? Wait. It needs to, like... It needs to only be one of these. Somehow. Like, for example, if this is... if this number is 2 to the 3 times 5 to the 1, then it won't be divisible because there's no 3 here. But what we do need is that... Yeah, this is a VC. But it's also chilling, so, like, it doesn't really... It's not that big a deal. Like, I'm gonna try and explain everything elaborately anyway. I'm not try-harding this. Right, so if pi isn't divisible by qi, then like there's at least one of these prime factors that doesn't exist in pi. So for example, if you have 2 to the 3 times 3 to the 1, then this 5 doesn't exist, so pi is not divisible by qi. Otherwise, we assume that pi is like a superset of these prime factors, which means it has at least that many for all of them. Then what we have to do is we have to decrease exactly one of these prime factors to be lower than its corresponding one in qi. And the reason we want that is because, what? What is ORs? Oh yeah, sure. Slightly distracted. Not that distracted, slightly distracted. Isn't that its use in CP2 though? Like it's the bowing down. Right, so we want to decrease like one of these prime factors to this. So let's just like try all of them and then see which one reduces the number by the largest amount. That's the basic idea. For each prime factor, if pi is a superset of them, then how do you draw stuff nicely? It's mostly practicing. Just like I've done a lot of stuff with the mouse, so it's not that hard for me anymore. Okay. So if p is not divisible by q, then pi just works. So let's just do that. Otherwise, we assume that p is divisible by q. Cohen next Picasso when? Never. Maybe a paint Picasso. Otherwise, let's prime factorize qi. And we're going to do this by pulling out my trusty number theory template that I still haven't fixed yet somehow. So that's fun. I'm going to just... And I always tell myself to fix this, and then I never do. So every time I have to adjust it for my template. So let's like screw all this stuff, and then no, let's just fix it now. Why not? Just doing some template management on stream. That works. Right, it was n plus 1, yeah. And then the other thing is some other stuff. You know, I'm never going to do this if I don't force myself to do it right now, so this is what I'm doing. Let's see. Right, and then we're going to fix it here. Okay, but I actually don't need this right now. I'm going to do it anyway. I think what I want is the factors, right? So, first you gotta like do a sieve. This is how my template works. Then, what the I call it? Factors? Okay. So then we're gonna just like count the factors. This works, right? Left this note to myself. Yeah, we can sieve to like 1,000,000 or something, that would just be fine. Can I explain the template? Sure. So like, I basically just wrote this as a black box to find prime factors and stuff. So first, I'm doing like the classic sieve of Eratosthenes because that's like a thing. You can just search that up. It's a very well-known algorithm. And then once I do that, I just use the sieve to make a giant list of all of the primes that I've figured out already. And then once I do that, I go through all of the primes, see which ones divide the number n, and then just like put them all on a list. But the trick is this only goes up to square root n, this finding of the factors. Because the idea is if you have two primes, a and b, such that a times b is greater than, or is such that a times b is like greater than or equal to n, or a times b is less than or equal to n, then one of the two is also less than square root n. Which means that, what it means is that every prime, or like, for every number, there's only going to be one prime that's bigger than square root n. So, that's the way the template works. So it only goes up to square root n because once we look at all the primes that are less than square root n, then we can like just be assured that either this last prime is prime, because otherwise it would be composite and then we would have some other things, or it's just one and then we found all the primes. But either way, there's only like one huge prime at most. So that makes this O of square root n and this just finds all prime factors of a number. This isn't necessary. So, oh, what is my words per minute? I actually don't know, because I type a lot faster when coding than like doing type eraser and stuff. Although I can usually get around 90 to 100 words per minute on type eraser. We can try that later if you want, I guess. Count. So now we're going to find, for this given prime factor, I'm going to find the respective power of that prime on P. So mod x dot first is equal to 0. This is the then we like take the difference in this, and we know that first of all, like we have this x and we want to decrease it by 1 to make it less than y, where this is x and this is y. So we know y is greater than 0, which means that the number of things we need to do is x minus y plus 1 operation. So that's the number of, that's like the amount we have to decrease. So we want the minimum possible decrease. So this is the power minus the power in Q, then and that's the idea. We go through each prime factor individually and try to decrease it as little as possible, and then we just try things. Okay. Oh, come on. Facts. I actually don't need to do that. I hate that I did this to myself. fix this here too. Yay, template management in the middle of a contest. Awesome. Oh, what? Not fix it here. Didn't fix it here, did I? Whoops, yeah. Anything else? Or is this fine now? Okay, cool. So now we can get wrong answer on the sample instead of... What? Oh, wait. Didn't actually do that. This whole thing is just like a series of confusion. Okay, 10.4, 179. Looks good. P mod Q is not equal to 0. Find the factors, do the prime factor stuff. I'm going to explain this more elaborately after the contest, so look forward to that if you want. Spent 15 minutes on A. How good is that? Okay. Alright, you're given an array A of length 2n. Consider a partition of array A into two subsequences P and 2 of length n each. Okay. Why are these statements so much better than the div2 one? Let's sort P in non-decreasing order and Q in non-increasing order. Okay, so reverse sort. So sort P, reverse sort Q. We can denote the sorted versions by X and Y. Then the cost is defined as the sum of absolute differences. Find the sum of f of PQ over all correct partitions of array A. Correct partitions, okay. Okay, so first of all, the first thing to note is that the order of the elements in the original sequence doesn't actually matter, because we're going to reorder them anyway once we do the operations, once we do the sorting. So we can reorder this original sequence however we want, which means we might as well sort it, because that might make our lives easier. So first sort. No, I haven't solved it yet. I'm just noting that. So first sort A. Oh, what, the profile is blocked? Oh, do they not allow that to happen anymore? Huh, interesting. That's sad. Probably not that big of a deal though, is it? Okay, right? Now, if this array is sorted, then... Whoa, big numbers, nice. If this array is sorted, then... We're going to pair the first element with the last element from B. The first element of A with the last element from B. And then the second element... Am I going to plug mbit? Yeah, probably later. Actually, I can plug mbit right now. Here, guys, we're hosting a competition. It's by my school. You can go to this link, mbit.mbhs.edu, and then, thank you for reminding me. You can go to this link, mbit.mbhs.edu, and then somehow I have 0 concurrent viewers. And this is a competition by us, so you can register right now. Look at this. It's a button that says register. It's amazing. You guys should do it. It's like, there are problems for everyone, pretty much. Like, for all difficulties. Yeah, it's online. You can read about the rules on the site, and the site is now in the description, so click on that. Go ahead, do it, right now. Do it. Do it. Do it. Okay, anyway. Let's figure this out. So, right. So we have some sequence like 1, 2, 3, 4, 5, 6, right? Also the mod is this. So whatever element we pick here, either this element goes towards A or it goes towards B. Let's see, the interesting thing is that this array is sorted, which means that we can kind of kill the absolute value condition. That's what we're trying to do here. We're trying to kill the absolute value condition. Let's say this element is in B. Let's just fix this element to be in B. Then it's going to be the smallest in B, which means it's going to match to the first element in A. So, whatever the first element in A is, that's a question. Okay, this is like, I'm assuming it's like bashing all the math and just like doing stuff. So let's try to figure out how to do that. If you, position's kind of annoying here. The best thing to do is definitely to kill the absolute value condition. I'm not sure how to do that though. That's the thing. Right, so we can assume this array is sorted. Kind of repeating myself here. This isn't good. What would happen here? Okay, let's look at this. There's 6 partitions, sure, 4 choose 2, and so we can think of it like 1, 1, 2, 2. So then there's some like stuff here. I don't know why I can't get a grasp on this problem. What is happening? We're taking some. What's like a possible strategy? So we fix some element, and we say it's either going to be an A or B. Let's see how much it contributes when it's in A. If we fix this element, what if we do it like this instead? So we fix, this is obviously n squared or something, but we can improve on that. So we fix 2 elements. Then we ask how many times are these 2 elements going to be paired up? With that in mind, what? It's a good question. Yeah, it seems like you'd be like a math god. Hi Gabe, how are you doing? Did you solve everything? Did you AK this contest? The annoying part is just the absolute value condition. Because, yeah, it just like is annoying. So if we say this element is going to be paired with this one, and like for example, in how many places will this be in A and this be in B? Okay, that's like n cubed. That's not good. Whoa. I don't think that's a good way to do this. If we still think about a single element, then how many like A's and B's are there to the right of it? Kind of. For example, declare that this element will be an A. Then there are a certain number of elements we can take in A from the left. Let's call that X. And then we can figure out how many elements we have in B on the right of this. It's a lot of messy combinatoric stuff. It's not really going well. I do not have a math background. Okay, what would you even do without the absolute value condition? Then like it doesn't, if it's not the absolute value condition, then it doesn't really matter what you do with B. It's kind of just like, yeah, without the absolute value condition, it would just straight up be the number of subsequences that contain this, which is, I think exactly half of them. Yeah, my chair is kind of squeaky, sorry about that. So this would be, if there's no absolute value condition, this would be n choose n over 2 divided by 2 times the sum of AI, or something like that. Or it would be weird, but that's the number of subsequences that contain this number. So the question is, how many times is this element matched with something less than it? And how many times is this element matched with something greater than it? An official rank that was a red who was not able to solve a single problem. That's going to be fun, then. By the way, I'm also streaming tomorrow's round because I'm like chickening out of rated contests. So, So I'll stream that at like a different time. Okay, I'm avoiding this problem. So how many times is this element going to be matched with something to the right of it? If we can find that out, then this is going to be perfect. Coding Shark style? Maybe. No, no. It's like very confusing. So this is kind of only dependent on the position and not the element itself. Yeah, I know. It's streaming live contest. So maybe there's just some sort of like magic combo trick we can do to find this out. Okay, right? So if we want this element to be matched with other elements in this, then say we take X elements from A on this side and Y elements from B on this side. So then this will be position X plus 1. So we want X plus 1 is less than or equal to the amount we take on this right side. Which is to say, what does that mean? So we can do that in n squared with combo, I guess. But there should be some better way to do this. I know there's always some like magic. Yeah, I saw that meme. That was funny with Anton, like commenting on the videos. Okay, so we have this n squared solution now. We just like figure out how many times this is matched with something on this side of it. And then obviously the remaining part is just how many times this is the other thing. Interesting though, because A and B are kind of like equivalent. So solving with 1 on the left, and we're solving with 1 on the left and 4 on the right in terms of this being in A. But then in terms of this being in B, we're also solving with having 4 on the left and 1 on the right, kind of. Which is interesting. Does this make anything easier, is the question here. Actually, wait, X and Y are related. I kind of forgot about that part. X and Y are like totally related to each other, right? Okay, so let's consider this element. Say there are A elements to the left of it and B to the right. Say this element is going to be in sequence A without loss of generality or whatever. Then if we take X elements from the right, this is going to be position X plus 1, and we took Y minus A on here. Or we took A minus, and to B, which I'm going to use orange for, we took A minus X elements. Which means this is like, what would this be? This would be like n over 2 minus A minus X or something. And we can think of it like we have n over 2 minus x minus 1 elements of B here. So this is like, combo is not my strong suit. I will admit this straight out. Combo is very not my strong suit, so I'm expecting to struggle on this. This is natural. This is not unusual that I'm not solving this quickly. So x, comma x plus 1. So like that just makes sense. But then the remaining number of elements from B we have is n over 2. This doesn't make sense. There's like something I'm missing here. Because this has to rely on minus. Yeah, I'm sure this will all like simplify out to some like multiply the array element by 2 and sum those kind of formula, but right now we're not there yet. So this I'm confused by this. This shouldn't make sense. Because if you sum these up, it's like definitely not oh, actually it is, I guess. Yeah, if you sum all of these up, then it's doesn't make sense. So now we want all x such that x plus 1 is less than or equal to n over 2 minus a plus x. And x is also less than or equal to n over 2. So if we like simplify this, wait, what? I feel like I'm missing something because this doesn't depend on x. That's the interesting part. This doesn't depend on x. Is that the mind-blowing part, that this doesn't depend on x, and therefore it's just interesting. Interesting. Let me make sure I did that right. So the number of elements in B we have is a minus x. We want position x plus 1 to be less than or equal to the number of elements in B we have on the right. Which is to say, we have the condition that x plus 1 is less than or equal to, this is div 1b. We have the condition that x plus 1 is less than or equal to n over 2 minus a plus x. Div 1b or div 2d, either way. By the way, this is my problem-solving process, looking at random things until something works out. It's not a very good one. So this is this true? Is that just it? If we take a certain number of elements on that, that doesn't make sense. It has to depend on x somehow. Because the less elements of A we have on the left, the more we have on the right, which means the fewer... Oh my god. Oh my god, that makes sense actually. If we remove an element from A on the left, and therefore we increment 1 by B, then we remove an element from B on the right, and therefore we increment 1 by A. So this makes sense, that this actually doesn't depend on X. And so this is only possible when A plus 1 is less than or equal to n over 2. Right now I'm solving for when is this less than the element it's matched with, which means when is it less than this. Alright, I guess this is the observation, that you gotta do stuff like this. Right, but I think this is a more systematic way of deriving the this than just like randomly looking at stuff. Like you can see here that this condition for every contribution to sum. I'm already doing that. This is like the condition for every element to be less than its counterpart in B. That it actually doesn't depend on how many elements you take. It's just that this must be not too big. Is that it? Is it A plus 1 is less than or equal to n over 2? Well, yeah, I'm being very careful to not be wrong because I'm streaming this, and I want to make sure that the solutions I'm giving are correct. So I'm being more elaborate than I usually would. So A plus 1 is less than or equal to n over 2. Alright, so say we have like n equals 5, and n equals 6. So then we have 4 here, 1 here, 1 here. Four here. Wait. Okay. So we have to have the condition that A plus 1 is less than or equal to n over 2. So let's say we do like this. Then we have two elements of B. Wait, that doesn't make sense. We have this here. Then this is an element, and this is an element. That doesn't make sense. Wait, am I right, or did I screw something up? Like this seems arbitrary. Plus 1 doesn't make any sense to me. That's the part I'm concerned about. The plus 1 is kind of unintuitive. Because it just doesn't feel right. I don't know. Right, so x plus 1. Less than n over 2. My algebra is wrong? Nice. I'm not good at math, as you already know. What's up, Lior? Yeah, he is, Everrule. Wait, no, this does work, I guess. And if we take some other amount... What have I done here? Something's messed up. Something is definitely messed up. Guess who lost purple in that round? Oh no. You're definitely getting it back soon, though. I know that for a fact. Reading, problem solving, and implementation skill using internet connection trick. Oh, I wouldn't have thought of that. Thanks. This feels fishy. Something's fishy here. I messed something up for sure. Okay, it's not actually, yeah, it's not actually a spoiler. I don't know what I've done here, but this is wrong, I'm pretty sure. Because otherwise, like, something else would happen. Ow. My head is not in the game today, I don't know why. But if we take this, like, thing here, and we say all the B's are gonna be here, then that's a problem, isn't it? Maybe it's like A-1 or something. Because otherwise, there's, like, no way we can match some of these. Wait, also you need an internet connection to submit, right? What is a decent rating in Codeforces? Really, whatever you're happy with. Because, like, it's just whatever your goal is in terms of competitive programming, just go for that. You don't have to compare yourself to what other people are. It's taking a long time. Forgot that the stuff is like backwards. Right. Take X elements here. I don't get what I've messed up. Wait, did Monogon even solve C? Wait, did he spend the whole time struggling on B? Oh, that would suck. Looks like what I'm about to do too. Yeah, no, streaming just like has that effect. I can't, this is why I don't screencast div 1s, because it like, it just makes it harder to focus. Okay, let's say we have something like 3, 1, 2. Right, we want this position in this prefix to correspond with this position. If this was an actual contest, would I have spent so much time? Probably. I mean, probably. I don't know. The thing is, this is like math, and I'm not good at math. Oh, is this Monica in the chat? Welcome. Welcome all. You can watch me struggle on this problem too. Make you feel less bad, maybe. Because right now I'm 48 minutes in and I'm confused over my own, like, equation, so this is, not ideal. So it's like, if we put this stuff here, then this will work. Or it won't work. Like, it feels like it should be A-1. That's the condition I'm thinking of here. Because that would just make sense. Otherwise, like... But I don't want to guess this. I want to figure this out. Div 1B is fine if you like math, but I don't like math, so it's not, Yeah, if you like seeing me struggle, then this is the perfect problem for it. So, Jesus, just threw my phone on the ground. Yeah, if you like seeing me struggle, this is the right stream for you. And actually, if you like seeing me struggle, you should probably watch the other screencasts too, because there's a lot of that in the other videos. Trust me. And you know, maybe possibly subscribing is also an option. Just a suggestion. Like, this has got to be A-1, but I don't know where to get that from. Start again, you mean like restart the everything? So we take x elements here, which means we take a minus x on this. And then we fix this to be in A, which means that this is going to be position x plus 1 if we take x elements from here. Position x plus 1. It's like top tier doxing right here. Oh, come on, Leo. You were purple already. You already were purple. Did you even hold up to your promise? You didn't start YouTube after you did get purple, did you? That's the sad part. So this is going to be position x plus 1. Which means that on this side, we have n minus 2 minus a plus x elements of B. And we want, yeah, Leora, start YouTube. And also look at Algorithms Conquered. He has a good channel. It's got some like OP stuff. Stuff that I don't even know myself, so I should actually probably watch these videos. Okay. This is a total mess right now. So then we end up with n minus 2, n over 2 minus a plus x. Yes, it is a very blatant promotion. Is it even possible when you have something like this? Like, say you have, say you have this. Say you have 3, 1, and 2. Like, is there any sequence where this works? For example, this one. So you got something like this, which means that this is the second thing, so it doesn't work. Yeah, everyone, can you help me? I don't know what I did wrong. I know this should be a minus 1, but I don't know why I'm doing this. You're allowed to help me because I already know what it should be. I just don't know why it's that. Or actually, if I'm wrong, tell me I'm wrong, but don't, I know this has got to be a minus 1. And therefore that, is this true? There are edge cases? Sure. I didn't see anything. What would be the edge cases even? E to the 7th times log n plus I. Nice. Doesn't even depend on the array elements. wrong in the first part? Take a minus x. For b. If you have the math gene, yeah, probably. This is position x. A and B are arbitrary lengths. A means this is going to be in sequence A. I'm trying to do contribution to the sum here, but I'm not exactly sure what's happening. So this is x, this is n over 2 minus x minus 1. Which means that as a mod, give me contribution. This does seem like algebra bash. That's the approach I'm trying to take with this, at least. It's not exactly working that well. Because something's going wrong, and I still am confused on what it is. It's just, I don't know. If you have something here, you say you're going to have A elements, and then one element here, and you say you're going to have B elements. Try div 1E, maybe I'm lucky today. That's a good joke. Yeah, wrong modulo. That happened to me too in some contest. It was sad. It like stopped me from getting CM or something. Yeah, I kind of just like redefined n to be the... I redefined n to be 2n, because why not? So it doesn't... It's the same idea. I'm just being confusing in terms of my own terminology. This is 1b and or 2d. Do algebra in reference to an example of x, a, and b. So like you take one element here, and then this is element 2. And then you have two minus this. Yes, I know the observation. I already get this stuff. I'm just trying to derive it correctly because I'm confused over why my thing is wrong. So this is position 2, specifically position 2. And then here we have one element over here. What have I messed up? So this is 1 plus 1, right? Like we want... Take x elements here. X plus 1 is less than or equal to... It's the number of elements we take. I just realized what I'm doing. Actually, I just realized what I'm doing. I just confused myself over everything. Okay, this is actually right. This was right, I think. And then it should be that a is less than or equal to n over 2 minus 1. That was what I was thinking this whole time, but I for some reason couldn't like think of that. I'm pretty sure this is it. For this to be like a lesser element, then a must be less than or equal to n over 2 minus 1. And therefore, all ways to choose n over 2 from this is possible. Meaning that I'm just being stupid. Yeah, I already have that observation. That's like the main idea, right? That if you subtract 1 from this side, it does the same for the other side. Or is there even more? Is there even more than that? Because that would be annoying. But you can, like, if you, as you could see, or as you could have seen, I got this observation by realizing that this formula doesn't depend on x. So if you do the algebra bash, you can kind of reverse engineer what you need to know. But it's also possible to just make the observation and then totally, like, ignore everything else. Alright, so this is a is less than or equal to n over 2 minus 1. 0 indexed? I think so. It shouldn't matter that much. Or it's 1 index, maybe? Yeah, 1 indexed, I guess. So if so, then any possible selection of the elements is possible. And there, because the number of elements you take is less than this. I mean, like, how would this work? You're taking more elements. You're taking at least as many elements in A as you would for the first sequence. So therefore, anything here can either be the first or the second because you have enough like elements that you can both make the whole thing in sequence A and like the whole thing in sequence B. So what I'm getting at is that there's like this formula for like 2 to the A, I think. So that you can take this many things. I made this huge canvas so I can do all this stuff. So now, say we have this element. We have A elements on the left of it, and B elements on the right of it. Then there are 2 to the A possible ways, provided if A is less than or equal to n over 2 minus 1, then there are 2 to the A possible ways to select elements for the first sequence. And then from there, what are the basics? What are the basics in this kind of problem? So the number of ways is Alright, I hate this chat right now. This is annoying. 2 to the A ways, right? So like this is the number of ways for this to be the lesser element. Like this doesn't feel wrong, that's the thing. Is this just straight up wrong? Because this feels like it is getting somewhere. This sort of contribution to the sum thing. where it's interesting how they give different values of n in all of the samples. Two to the A. Can't think and read chat in the same time. This is like disorienting. I'm gonna not read chat for a bit and just like focus on this. Alright, so this is 2 to the A, where we have, if this is less than this, like say we have some element C here for constant or something, then for this to be on the lesser side of things, we have 2 to the A over here. But then in terms of B, for this to be on the greater side of things, interesting. This whole thing better not cancel out. So this is either on the greater side or not the greater side. So if this is true, then we get 2 to the A. Otherwise, A is greater than or equal to n over 2, which means that this is going to be on the left side, so we get like, so this is like negative C times 2 to the A. And otherwise, this is going to be on the greater side, which means that it's C times 2 to the B, for example. But then if we consider sequence B, then it's, I think, the same idea. It would be the same idea because it's just like the same matching, but in reverse. So if we consider consider how many ways we want this to be the greater element on this side, then it's just like 2 times that, I think. Wait, does that even make sense? Doesn't seem like it makes sense. The answer is always even in these samples. That's interesting. But this looks like something. Doesn't work with the samples, huh? That's interesting. So on this side of the array, on the left half of the array, it's like these negative things, and then on the right half, it's these positive things. So yeah, it's so hard to wrap my mind around this, but like it should be the same for the B's. That is, if we want this to be on the greater side, there are just a certain number of ways to do that. So I think it's like the sum from I equals n plus 1 to 2n. Now I'm going back to the original n. So that's like stupid. Original n of like ai times 2 to the 2n minus I plus 1 or something. I don't know, let's try it out. Does it actually work is the question. Is the question. Well, we get some stuff here. Let's work for the second sample. So it'll be 2 times that difference. And then 4 times this difference. Interesting. Maybe there is also something else. Such as 4. I'm not solving from the samples, I'm trying to find out if it works with the samples. I have this ball that I'm opening and closing. It's not actually a weird sound. Okay, my problem is that it's not working for the samples. I'm pretty sure it isn't. Because, like, you have 1, 1, 2, 2 on this one. But the problem is, like, the difference is 1, then you have 2, and you have additional 3, maybe. Bless, something's messed up. Yeah, we're pretty far into this contest already. I've been spending a while just trying to, like, flesh this out and make sure it's actually not wrong. But it looks like it's wrong, which is the sad part. So it's C 2 times 2. I do hack solutions sometimes. 2 times 2 times 2. It's 11, it's 12 minus 6. Something is indeed messed up here. Or is it? Make sure the modulo is right. Yeah. So now I'm stuck again. I'm not exactly sure what's wrong about this. Well, so like say we have this array, and then we're trying to find the contribution of this element to the sum. Then no matter what we do in terms of A, it's going to be the lesser element. So we can either pick this element for A or we can pick it for B, but either way it's going to be the lesser element, BA. Therefore, there are two ways to use this element to be the lesser element. And then for the greater element, it can't be. There are two ways to use this element to be the lesser element. I don't actually, what am I saying? I'm missing something. Yeah, it can't be just these powers of 2's, I guess. There should be some combo involved in here, I guess, that I'm missing out on. Or in this case, it's picking some amount of elements to B and A. Okay, this isn't right. There's more to it than this. Gabe, did you crush this problem, being a math god? I assume you did. Yeah, Lord Omkar has not blessed me, sadly. Did it take you an hour, though? Did it take you an hour? What do you consider failed? I have the water bottle right here. It's not saving my rating, though. This is so annoying. I'm glad I skipped this round. I actually just realized that it doesn't. I don't know why I'm overcomplicating this so much. Like, okay, we say this is going to be an A, right? Which means that like we have 2n minus 1 elements where we can like do anything we want because we just proved that it doesn't matter what we do with this. So we have 2n minus 1 elements, choose m minus 1 because we have to put A somewhere. I think that's just I think that's just it. I don't know why this. Okay, that's actually stupid. I hate math. It doesn't. Everything's independent. It doesn't matter what we do with A and B. So we just straight up have n minus 1 elements to pick from a sequence of size 2n minus 1. That's annoying. Let's see. Is this actually right? Maybe it isn't. Perhaps there is something else at play here. But it's like. Do I avoid clicking the wow? Well, no, I just like seeing it, to be honest, because it reminds me of a time where it was better. Because the time I got plus 149 is still my best performance to date, so I want to leave it as an archive. By the way, Monogon, are you streaming round preparation yet? I would be very interested in seeing that. Yeah, I'm an idiot. We get it. It took me this long to find that. I know. Why does this also feel wrong somehow? No, it's not. It's not wrong. This is right. So the answer is 2 because each element 2 because like everything can be in either A or B. And then times choose 2n minus 1 times 2n minus 1 choose n minus 1 because each like thing can be in either A or B and it doesn't matter. That's the whole point of this observation. And then times the sum of the last n elements minus the sum of the first n elements in the sorted array. Let's try this. I think that works. I'm gonna be lazy. I have this mod template that I'm just gonna copy in and just do all the stuff with it. 2I is less than or equal to 2 times n minus 1 plus I mod 2I. Now this is the easy part, writing the code. Can't type. You guys happy now? Is this satisfying that I finally get this formula after so long of doubting myself? Oh, test cases. Let's see if I code it right. I did not code it right. Okay, what have I done? It has to be 2 times because the mod is potentially less than the actual array elements. No, he means, I think he means this specifically. But potentially these array elements are like less than huge. And actually, I don't think it would actually make a difference because we'll fix it later, but it's like, whatever. I'm just being careful. Okay, but somehow I messed up this formula. I don't know how. Does it even get this sample right? Where does it start getting it wrong? 24, okay. So this is 2n minus 1, choose n minus 1. What have I done? What have I done here? Minus AI plus 2 times mod. Mod. Why is this wrong? That's 2. So NCK is 6 somehow, which is not right. Is it? Oh, I forgot how factorial. Wait. What am I saying? I forgot how factorial works, right? Okay, let's test it on this one. Yeah, we got it. All right, cool. Just test on this one. This is like manually computing and choose K. Alright, there's absolutely no way I can expect anyone to follow this thought process for an hour. So after the contest, I'm going to explain what happened and how to like get to this thing, for sure. Okay, I'm going to go to the bathroom and take like a 5-minute mental break from that. I'll be back in a second or so. Mute my mic because there are sounds. So let me explain why that took an hour. Because the stream mentality is very, very different from the contest mentality. First of all, it's hard to focus when you got like 12 people in chat telling you to do different things from what you're doing. Which is, I mean, I understand it's just like slightly disorienting. And also the fact that I didn't want to be wrong. So everything I like I wanted to just verify everything I was saying, kind of. That is the idea. And again, this is a very not serious contest. So okay, let's do what we can from this one. Let's try and solve C, I guess. New academic year has started. Berlin's University has N first-year students. They are divided into K groups. Some of the groups might be empty. Among the students, there are M pairs of acquaintances, and each acquaintance pair might be both in a common group or in two different groups. Okay. Alice is the curator of the first years. She wants to host an entertaining game. Oh yeah, okay. I mean, I will admit though that even in contest though, it would have taken a long time for me to figure that out. I just wouldn't have been so like rigorous about it, I guess. She wants to host an entertaining game to make everyone know each other. To do that, she will select 2 different academic groups and divide the students of those groups into 2 teams. Divide the students. Does that mean she can... Okay. Wait, how does that work? Does that mean she can, like, mix up the groups? Or the groups are against each other? Unfortunately, I can't give you a contribution in the stream chat. Wish I could, though. Yeah, notes section, probably. Okay, so, stuff like this. Select the first and the second groups. Okay, so it's just combine the 2 groups, then form a team out of them. That makes sense, I think. Or then form teams out of them. And there are no acquaintance pairs inside each of the teams, which means that the graph has to be bipartite. I guess that's the idea. So, how many pairs of groups she can select such that it will be possible to play a game after that. All students of the 2 selected groups must take part in the game. Please note that the teams... Oh, yeah, okay, sure. Don't have to coincide with groups the students learn in. Moreover, teams may have different sizes or even be empty. But the whole point is that the graph has to be bipartite. I think that's the idea. So how many ways are there to select 2 subsets of vertices such that the union of those 2 subsets is bipartite? Interesting. So first of all, I think we can solve for each subgroup itself. If any like singular group already isn't bipartite, then like there's nothing you can do. So we can assume that the groups we're working with are bipartite. And then we need to find out if combining 2 different groups creates a non-bipartite graph. And interesting. So any 2 groups that don't have an edge together are like any God, what's going on? Yeah, Chinese people are crazy. Or some of the well, I mean not all of them obviously, but like there are a lot of crazy Chinese guys who just reach LGM in like a year and at the age of 10 and they just like go on to be tourists or whatever. Wait, did I misread it? How come I never look at standings during the contest? Select 2 different academic groups and divide the students. And no acquaintance pairs inside each of the teams. Yeah, I did solve B eventually. You can check out the... Well, the final formula is at the end of it. But there's also like an hour-long process of just trying to work stuff out, and it kind of is hard to follow, but it's all there eventually. And there'll be an archive afterwards. Wait, it has to be, it's bipartite, right? Am I doing this wrong somehow? Because if not, then like you want to select 2 subset. You want to select the subset stuff so that... Okay, B was not intuitive to me, honestly. You gotta like have that observation and then like work out the condition and just like do stuff with it. I think that was my way of doing it because it like I didn't even like wrap my head around it until contribution to the sum. Primary school, Jesus, yeah, they are insane for sure. Oh yeah, link cut tree, even worse. That is insane though. Learning it at all. I don't even know what that is or what it does or anything. All students of the two selected groups must take part in the game. Wait, why is the condition? Isn't it bipartiteness? Where you would want to oh rip. Is that what happened to you in the contest? What did you interpret it as? Was it something harder? Whoa, geothermal. How you doing? Okay, so you want to select, you want to find out how many pairs of subsets form a bipartite subgraph, I guess. Oh, I see. Yeah, that would be different. Let's like consider the big graph. What's the first sample? So you got something like this. Ba-boom, 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 ba-boom. And then all the edges just kind of exist. What is it? It's this weird kind of thing. And then the groups are like so. 1, 1, 2, 2, 3, 3. So all of these subgroups are bipartite themselves, which is fine. So consider two groups that don't even like they aren't related at all. Like for example, we have something like we have these groups that just kind of exist and are chilling. So these are both in group 1, these are both in group 2. Then because all of these already have to both be bipartite, then if there's no edge between these two groups, then they're automatically also bipartite. Like the union of the two is automatically also bipartite because it's just like it just is. Why would it change? There's nothing to change it. So it could be easier to find out of the groups that have an edge between each other, of which there are at most m, because that's how it works. Of the groups that have an edge between each other, how many of them are bipartite? Okay, these numbers are big. In general, the way I would go here is to try to do something with square root, but I don't think that's possible. In any case, maybe square root is possible. I don't know. There's a 3-second time limit. There's a lot of stuff going on though, and all the constraints are huge. Probably so you can't do accidental brute force. But I wonder if wait, maybe it's easier than that. It might actually just straight up be easier than that. Yeah, I'm doing the div 1. So we have two bipartite graphs. Let's say we have some coloring for them already, because like there has to be a coloring because they're bipartite. I don't know, just some random graphs that we have. And we'll say the first color is red, red, I said, not the same color. So the first color is red, and the second color is, for example, purple. I don't know. Then say we're going to add some edges between these two components. Where they're not necessarily like, there can be many components, but the idea is, say we do this. So we have this edge. And this edge means that, like, because the entire coloring can be derived from one node, this edge means that for every other edge, this has to be the same color between them. Because otherwise, I'm pretty sure that's what it means. Because otherwise, we would just be like, it wouldn't be bipartite. Because now we have this connected graph, so we can define this whole coloring by just this node on this graph. And so there's no point in recoloring. All we can say is that we'll say that these colors are now inverted if this edge exists, which means that for any other edge between the two groups, it must be the same coloring. Otherwise, it would not be possible. So I think that's it. I'm not sure if I can implement this in time, but I think that's it. So we'll count the complement. We're interested in the number of pairs that we can't choose. Paint is indeed superior. It'd be like really nice if these groups themselves weren't bipartite, but I guess they are. So we're interested in the number of groups that we can't choose. Let's assume all the groups we're working with are bipartite, which means now we have some like magical graph here and we have some magical graph here. Both of these represent two different groups, and we have some edges between them, and we want to find out if this isn't bipartite. Because if there aren't any edges, then we automatically know that like it's not going to change anything because both are already bipartite. So we want to find out how many are bipartite. Okay, I'm glad they give the groups first because that's like a nice implementation thing. Okay, well, even if I don't implement this in contest, I'm still going to just upsolve it eventually. So once we do this, then we have this condition for checking if the union of these two groups with the added edges is bipartite by saying that we add some edge between this. So we add this edge. Now we know that this coloring is correct, but if we have any other edge that violates this coloring, then it's not going to work. So every edge either must connect two opposite colors or connect two colors that are the same. We can't have both in the same type of thing. I think that would be how it works. Okay, let's try that. So first, read int n. So we'll define this to be a JSON list within group. This is for me to keep track. Right, okay. Now, okay, I'm gonna probably start ignoring chat now because I want to focus on this. See if I can implement this in time. it's the same thing. So first we're gonna do this. Then let's see. Now we want to check for each group if it's bipartite. How do we do that? How do we check this? I think that works. If x valid.push back I, which I can combine these. So then void check. This should be a Boolean check. Put this here. So if visit x return, set that to 1, set the color. Check if it's possible. This is the reverse of the color for each adjacent node. If it has the same color, then we're like screwed. Otherwise, do the DFS to that node and the other color. I don't compile with Notepad. I use a separate compiler. Okay, return possible. Now, this will do both the coloring and the checking at the same time. So that's good. Right, okay. Now, it's just some things that make things more convenient. So, for 0 is less than n, I plus plus. For int x OH I pairs dot insert get AI AX. Solving for the number of invalid pairs now. So now what we're interested in is wait. Yeah, I know it did. I may or may not have set up that video to slightly blow up, and it did. So if I do similar things and I do them the same way, it'll like also work out quite well. But I don't really have content yet, so I'm not really sure what to do about that. I know it's definitely a good idea to do that more though. So let's see. I'll keep answering questions after this. I'm not sure I can implement this in time, to be honest, but that's not a big deal. So get check x dot first, check x dot second. Int comp. Comp x equals 0. It should be color. Time left 5 minutes, so I gotta clutch this. Right. So, for if, let's see, groups dot size. Wait, there's a better way to do this. I'm not getting this. It's sad. Parallel long y of t edge x. A equals comp y dot first. B equals comp y dot s. If will it be? What? Yeah, this is sad. Like, very close, I'm pretty sure. Just not there. Oh, wait. Even if I like finished implementing this in time, I don't think it would be correct for sure. So, whatever. Yeah, let's just submit it. Submit what we have. Why not? It's probably like not even gonna get their first thing right, but yeah, okay, we tried. Well, let's yeah. Okay, no more tension. So Notepad++ and Paint. Yeah. Well, I have this compiler called Cygwin. GG. RIP. I have this compiler called Cygwin, which is Like, it just does some cool stuff. Okay, where does it get to? It's binary search on the place where it crashes. Yeah, but this compiler will do stuff for me. Okay, so it's right here. CX. 010212. What's N? Yeah. So it dies at 1, 2. Why would it die there? Die here at 2, 4. Yeah, Notepad++. Let's go. Why rel? Why is it crashing? Where is it crashing? Oh, wait. Oh my god. Okay. That's annoying. How did I... Okay, well, it gets that wrong anyway. So, what is happening here then? So choosing 1, 1 and 3, 3 makes it impossible, I suppose. Yeah, so the problem would be 0, 2. How are they always different? Comp. Wait, what am I saying? Oh no, okay, that's sad. Y dot first, Y dot second. Yeah, it doesn't have to be the components, it just has to be the values themselves. Okay. Alright, that's wrong. Is this wrong? 3. 0, but something's wrong here. 1, 2, okay, the whole thing is a cycle, sure. Oh, I see, it's more complicated than that. Because it might possibly combine multiple components. Okay, so maybe this whole thing is wrong. Nice. Or maybe it's just not as simple. Yeah, it might just not be as simple. Let's see. I see what the case is. The case is something like this, where these are connected maybe, and then you have 2 edges like this, and then all these edges will exist once you combine these 2 groups together, and then that wouldn't work because it's an odd cycle. So maybe it requires another check for bipartiteness, where it's like, I think you like make components out of these three things, and then FST? Oh no. How? That's crazy. Alright, well I might as well check my place. I'm pretty sure it's like very bad because of not getting C, but how did this do? Yeah, this is quite bad. But whatever, it was a string. We probably would have had C and or FST'd it in everything. So that's fun. Yeah, I'll like talk about all the solutions again. Wait, what do you need rollback for? Why would you need rollback for DSU? Maybe you would. Let's see. Yeah, that might be necessary actually. I'm not entirely sure. There's some sort of like stuff going on here with components and things, I suppose. Although it's entirely dependent on the number of edges we need, isn't it? Let's see, it's some sort of like DSU-like thing. Where it's like we have these like bigger components now, which consist these components that represent components. And then we can think of a bunch of edges between these components that say like either these must be the same color or these must be different colors. And so but again, still the only components that do matter. Yeah, I'll cover the problems. I just want to solve this one first. So the only components that actually do end up mattering are the ones that are involved with the edges. So I think we can make a new graph out of this. And then we can say that like we have some constraints between these. And then we can get TLE because it's set operations and we have 5 times 10 to the 5th. I think that's a good plan. What do you guys think? Should we get TLE? I think that's, yeah, why not? So what happened here is we make this new graph, and we say that in this graph, these colors must have edges between each other. Wait, I don't see why you would need DSU here. Like, you can just make this other graph and then rerun the bipartite check on that, couldn't you? Let's see. Oh boy. So we make another one. So the problem here is that it's not this simple. It has to be a bit more than that. But we have this relationship, and we say that vector pair. Then And just to be careful, we clear all these edges. Now we say so now we let's see. So right now I'm implementing the DSU of this, or the bipartiteness of this massive graph. And we kind of just like do the same thing. Bool check 2. And it's like the exact same thing, except we mess with the edge list a bit. Temp edge. So if y.s, that means these must be different. So if these are the same, otherwise they must be different. No, wait. And these must be different, otherwise they must be the same. So we do this. Y. And C. Kind of like overwriting this graph, kind of. Does it compile? It does not. Why does it not? Oh wait, this should be y.first. Yep. All these are the node, and we handle the color relation. Nice. What's with that? Oh wait, y.f equals the component of it. And we get 1. So 220. Why is that wrong? Oh wait, color y.f. We have to make sure these colors are actually set, otherwise that wouldn't make sense to even think about that. And it still doesn't work. Get rid of that one. So, what? Let's put some more print statements down at this point. Not entirely sure what this is. Somehow we visit the same node twice. I don't know what's with that. What? So we do the same, what? We're visiting the same node twice somehow. Or is it just the exact same edge that exists? Somehow this edge exists twice. Oh, because it's between the two components already? How? What? Wait, TJSON is the nodes themselves. Then we're interested in these components. And we like do this. So before it's 0 and 2, which is totally fine. We're solving for components 0 and 1. So this would be 1 and 3. But why would they be together? They're in different components, aren't they? This is debugging 100 right now. So color is going to set components, because that's like what it does. G equals 0. Color will set components, right? Oh wait, we don't need this. Targ equals x dot f. And then targ equals x dot s. I'm surprised that passed the samples. Nice. Okay, now I think everything is better. 3. -1. Cool. How the hell is this -1? What even happens here? How do we have more pairs to check than are valid? Yeah, I tried to get C in time. I didn't. It was sad. I got runtime error on test 1. Now I'm getting -1 as an answer, which I'm like very confused about. So we have 1, 2, 2, 3, 3, 1, 1, 4. Oh wait. Okay. Why? Yeah, okay, we should only enumerate the valid ones. And something's still wrong here, because this should be, no, that's right. Okay, sure. No, wait, this should be groups. So this should be X, and this should be AY. Because X is a group, but Y is... Huh. Oh, this is fun. Okay. So X is a group. That's fine. And then we want for each node, hello, Y of each node in the group, X. And then for this, we have that going on. For int Z of OEdge of Y, then we're interested in adding a Z to it. Still get -1. How do we have pairs? None, these groups aren't valid. Bool, okay. So now OK represents if a group is bipartite. So now we finally get 0 for this. It's like a requirement that we have to fail at least one sample. So, oh, cool. So we can get rid of that, get rid of that, get rid of that. What else are we printing? Just the colors. Alright, let's do a sanity check. So read in the variables, look at the values, push that into the group, C into X to Y. If they're the same, do the group things, otherwise don't do the group things and do the intergroup thing. Then do some memsets. Check each thing if it's bipartite or not. For the ones that are both initially bipartite, find the pairs that are attached to each other by saying for each valid group, for each member of that group, for each edge adjacent to that member, put that edge in if both things are valid. Then for each pair, do coloring on each group independently. Then for each pair of edges between the group, I guess, find the relationship, set the components, make the relationship between the components, and then here you have the second bipartite check, and with that, like reset the stuff. So now this is just simply some pair stuff. This is the same code we used before, and this is just checking if the colors work. Let's try it. See if we can fail system tests or something. That would be like impressive. Nice. Wrong answer on test 7. Okay. So something's wrong. Something's wrong though, as you just saw. Something's wrong. No ors at least yet. Maybe later. We'll figure out what's wrong first. So if visited X, already be done. Otherwise, visit it, check the color, check the component. If it's possible, this is like initial bipartite check, so all edges mean that they're different. So do some like Y stuff, DFS. Just do the coloring, yeah. ++ big G. This is setting components and stuff. So DFS2, component of x is equal to g. If the colors are the same, impossible, and then make them different. Otherwise, if the colors are different and both colors exist, not possible. Otherwise, make them the same. And we guarantee that color x is greater than 0 because it's already being set for each edge. I'm in no shape to do the ABC, to be honest. I think this will be the end of the stream once I finish this problem, or conclude that I didn't finish it. But for each value, if it's not visited, then check the component. That's what we want, right? It's not visited, check the component. And then do the coloring and stuff. Wait. Oh, that could be a problem. Is this a thing? So 1 XOR 2 is 3. No, I specifically want a set because it should be, I want it to be a set because it's just like not revisiting stuff. So each thing should be in exactly once. I don't think this changes anything because 1 XOR 1 is 0, 2 XOR 2 is 0, and 1 XOR 2 is 3. So either way, it'll still work. But I guess it can't hurt to try this anyway. So set them equal to their components, then do the temporary adjacency stuff. Put the related stuff in. G equals 0, and it's plus equals check 2 related, or not check 2. Then clear the adjacency thing. I don't understand. And it's failing on a big test, not necessarily a small test. Yeah, face reveal coming possibly soon, but probably not soon, but possibly. This stream has been good, though. Like, look, these numbers are insane. For some reason, there's this gap here where it lost the data or something, but these numbers have been insane. Guess this is the peak at 135. Yeah. All right, what's wrong? Let's figure that out. This is the number of pairs. This is the number of invalid pairs. I'm so excited. Debugging. Related. Alright. Yeah, I checked that already, that the components themselves all should not be bipartite. And then I'm only working with the ones that are. This is problem div 1C. Seen to x to y. Right? Am I doubting the input now? Come on. Ci is up to k. Do I even use k? I do. I use it for that. Maybe I'm messing with n and m somewhere. Well, the only thing where n is really necessary is like the components stuff. Because otherwise, like every yes, this is Notepad++. Notepad++ is objectively the best. Objectively and subjectively. And like all dejectivelys. Wait, I've always used memset for Boolean and that was fine. Because it would just fill the whole thing with zeros anyway. How to debug? This is a good question. Yeah, I'm not really sure. What I usually do is first try to just scan the code again, and then I try some more sample cases, and then if neither of those work, then I try and like rethink the whole idea. Grade 12th. So, so what is this? Let's try some weirder samples. Let's do something like some cycle or something. Does it pass any of the big tests? Not really sure what to look for here. So let's make a case like this. 7, at least 6, 2. No, it's not dev C++, it's no bad++. It's better. It's strictly better. Would I suggest Python? If you already know Python, I guess if you're familiar with Python and know like the pitfalls of it, then it can't hurt that much. But if yes, Notepad++. But if you don't know any languages and you're trying to find one to learn, I definitely recommend C++ because Python has a lot of like things that make it hard to use it for CP4. And yeah, I'm still on problem C. It's taking a while. At this point, I'm just debugging it. After this, I'll go over solutions and then probably be done because this is tiring. So I'm not entirely sure what happens here. So we can make this graph or something. 1, 2, 2, 3, 3, 4, 4, 1. Then 5, 6, 6, 7. And we can make some edges between this, I guess. Or it would be like so it'd be 1, 1, 5, and 2, 7. How to debug on large test cases? What do you mean? What would that mean? Like having a large test case and trying to debug with it? Or, what is Free Fire? Having a large test case. System overflow thing. Oh, shoot, I am. Whoops. Oh, shoot. Yeah, thank you for finding that. God, I would not have seen that. Jesus. Wait, how did that compile? Oh, okay. Yeah, it was using the wrong adjacency list, I guess. Oh my god. Yeah, thank you, Nika, for finding that. Jesus, that is so annoying to have done. Okay, well, hopefully I would have found that eventually, but I don't even know, honestly. That's like such a small thing to notice. Now what? Is it time to fail system tests or something? It got wrong answer 7 because I was calling DFS from DFS2 instead of DFS2, which I would guess is a copy-paste error that I shouldn't have done. And there's always some sort of like inherent danger to doing stuff like that. Probably a better idea to rewrite it or not call it DFS2 maybe, but certain things. Okay, well this is hanging, so it's probably getting some sort of wrong answer. Yeah, possibly 2A-E. Well, what's happening with that? So I'm making exactly one edge for every, making one edge for every component. Why would that 2A-E? Time limit exceeded on test 15. Okay. So there were a lot of tests before then that were fine. Wait, is that a system test? Wait, I want to find that out. Of the people that FST'd C, did they fail this test? 27, 29, 32. Wait, why would DFS be too slow? Isn't there like only one edge for every thing? The way I have this set up, I thought there would only be one test, like each special edge between nodes would have a thing. How? Oh, debugging with n equals 5,000? Okay, that I'm not actually sure. That's kind of OP. Wait, check 2 is n squared. I do have fast IO. I have set that up here. I'm not passing this by reference, but wait, does DFS with Ackerman actually, or does DSU with like the Ackerman stuff actually perform better than DFS itself? I've seen that happen like once, but huh, interesting. Wait, okay, I feel like this is some more sort of inherent issue. Partially because I'm not using Kotlin. Does this make that much of a difference? Let's try that. It doesn't, I don't feel like I don't know. Because this would only be like, yeah, same thing. Still test 15, I think. Because this is only like being passed once. I'm not passing this in the DFS. This is only so I can have the nodes that I need to look at the components for. Do you see with login passed in contest versus DFS? How? That's crazy. I guess DSU is crazy fast or something. Maybe it's have an idea. Let's speed up some constants. This should make it so the overhead of vectors isn't a problem. Ideally. Imagine like caring about penalty. Does that make it faster, or is this some sort of fundamental thing? Yeah, I feel like it's a fundamental thing and not a constant factor. I'm just trying to tell the difference. Yeah, I know, but like at this point, it's like, I mean, it's past the contest anyway. I'm just upsolving it. Trying to figure out what happens. These kind of problems always like mess with me somehow. Where there are like 12 different arrays you have to keep track of, and you have to make sure you always do yeah, that didn't do it. That is a trick that's worked before though. I've used it for like CSES to get the fastest program once. Alright, this is just an annoying thing in general. So we look at the groups, and then these specifically aren't the groups. These are we make these between the groups, but otherwise it's not a big deal. Like something's. Oh wait, why? Why am I look? Why I forgot that I got the right answer, and now I'm getting tealy. Nice. So these are the pairs with at least one edge between them. Yeah, I know it's fine to do it with DSU. I've done that before. I just don't know why this is failing. Because theoretically, this should only be O of like n per. It's O of the number of. How popular is the McDonald's near my school? I don't know. I've never actually been there. And first, I just want to make sure this isn't accidentally n squared. And then, if that's necessary, I'll check I'll do the DSU thing. Actually, I guess it can't hurt to try. I'm gonna copy it in from a previous problem though, because I've already done that. So, Leo, do you remember that duel we did where we had to do that in the problem? Do you remember what that was called? Because I don't, but I want to, because that would make this a lot easier. Is it this one? No, not that one. Because like it was that exact thing that we had to do, and so if I could find that problem, that would make everything easier. I have official, unofficial. It wasn't Battle Lemmings. Oh yeah, okay, this was the area. This one? It was this one. Perfect. I'm gonna paste this in with the rest. Maybe it's just the set operation, actually. Actually, why do we... Wait, hang on. Let me just try not doing this, and instead, let's just make this a vector. Because I think that the fact that there are duplicates doesn't actually make that big of a difference. I'm gonna try ignoring the DSU. This should be vector. Let's try that. If it doesn't work, then I will do the DSU part. My IDE is Notepad++. It's a very good one. Okay. I just delete something? I'm even running on test 1. Is there an issue here? Why is it dying on test 1? Oh. Yeah, Notepad++ is the move. Okay, I guess it's gonna die again. Well, I'm not exactly sure what's happening here, but I guess we'll find out eventually. Yeah, TLE test 15 once again. Alright, I'll try the DSU. Okay. D.kill X. Wait, test 15 is an FST? Oh boy. Okay, so I'm just like totally screwed on this problem. Yeah, nice. Oh, is someone spamming in the... Okay, you should do whatever you need to. How do you time out for a specific amount of time? Is that just by default 300? D.merge y.f. Is that it? Should just be it, right? What? Merge with that color relation, sure. And it dies, awesome. Because I have to d.init n. Just can't hurt to make it n. And it gets 3. Wait, yeah, it does, great. Why does it get 3? Oh, because I don't actually... Yeah. Didn't actually do anything with the answer. This might get wrong answer because I'm doing the resetting wrong, but that's fine, I suppose. Is this the time to get wrong answer in test 29? That would be funny too. Oh, come on. It's still gonna die now. So even DSU doesn't fix this, so there's like an actual problem here, I suppose. What does this even mean? I don't know what this means. Okay. Once again, test 15 is doing stuff. Maybe there's some like other issue or something. I don't know why it would have an issue, but like, okay, this is clearly O of n, this is clearly O of m, this is clearly, this could be the problem. Like, I don't see how it would be the problem. Because it only uses edges that are within that group. So I don't understand. Pretty sure I just have like a terrible implementation. Yeah, it could be constant factor. Great. Oh no, do I have to convert this entire thing to Kotlin? Amazing. Pass reference to color. For what? Where? Oh, will this fix something? Because again, I'm still not using, like, the only thing I'm using this for is that really gonna make all the difference? Oh, god damn. I hate when this happens, because it always, like, stalls my, because it, like, tries to compile every bit of code until it crashes. So if I paste my entire program in by accident, it just totally screws it. Do I need 32-bit? Fun. Place. I guess I can try not using 64-bit C++. Why not? What? Oh my god. Not if you believe in yourself. Yeah. Kotlin is quite functional. Maybe it'll fail earlier. Okay, it won't. Wait, it still calls copy for each recursion call? What do you mean? I never... Color isn't a, Color isn't recursive. Like, this is its own function. This is like a wrapper function for doing DFS. That's why I didn't think it would do much. Okay, I really don't understand this now. So all this can be gone. Because we're doing the DSE now. Yeah, time limit is probably too tight. What were they trying to do here? How bad is the n-squared the solution they're trying to block? Wait, this is n square root n? I thought it was log. I don't know. Maybe it isn't. Oh, I see. Yeah. What type of problems that raised my CP level? That's a good question. It was a lot of like Yusuko style problems because that was the type of thing I was practicing for. So like it was essentially the ones with heavy data structures, probably graphs and stuff, and a lot of dynamic programming. Make all functions inline. I mean, I don't even use that many. Okay, I don't think that would help with DFS because the recursion depth is like way too high to I could try this. Maybe that would help. I actually do use that a lot. No, I'm 17. Okay, well, I gotta just like not use so many things. Okay. I'm gonna go on a mission to improve this constant factor now. And I don't know how. So T adjacent. Did I even use this? BFS for bipartite check. DSU does everything. Yeah, DSU would do everything actually, but like I don't see why this part would be bad either. It should be O of N. And I mean, I'm like, despite the constraints, there's no way O of N with like not a horrible constant could be that bad. BOI day 1 2020 trick. What's that? The maintain bipartiteness with DSU. Yeah, that's what I'm doing here already. Is that something different? Well, that's what I'm trying to do at least. No, I don't keep track of problems. What I do is eventually, by way of fate or something, I do end up revisiting old problems, and then I do try to solve them again. But I don't keep track of them. It would probably be a good idea to do that, though, to be organized about what you've done. And in terms of moving into 1900, I mean, whatever you did before, whatever you did to get to expert, like, I don't see why that would stop working. 1900 isn't really like a special point. As long as you keep learning new things and you have some sort of practice method that's been working, just stick with that. I don't know what's going on. Yeah, I know this map is having a constant factor, but I don't know what to do about it. Okay, I guess what I can do is first, I can make these longs. I can make this a map. Wait, I didn't. Oh my god, I'm an idiot. I submitted this with 64-bit, but I need to not do that. That could be the problem actually. I submitted it with 64. Now it's still doing the same thing. Damn. Ah. Let's do this now. Make this long, and then a.x. You want to see DFS? Sure. You can also look at these submissions if you want, since there are so many of them. It's like an hour-long segment of trying to improve this constant factor. I am so glad that I didn't do this contest. Yeah, I know. There's also completely rewriting it. I know that too. Oh, you can't see it? Oh, that's annoying. Okay, yeah, DFS code is this then. So it's if visited X, return, otherwise do the visited, set the color, set the component. For each edge, if it's the same color, it's not possible, otherwise do the DFS, and then return it. And this color function is for each thing involved in the group, reset it. And this is specifically adjacencies like only between certain elements in groups. So it would only be edges where both elements are in group 2, for example. I think. I think that's how I set it up. That's how it should have been set up. Yeah, I think DFS is fine. Let's try this optimization where we what? Oh. Yeah, I see. Let's try that. So you can compile. Reference everywhere. This should be like a very slight improvement. I guess DSU would be fast, right? I mean, there's a lot of cache misses, actually. That could be a problem, but other than that, it should be not that big a deal. True. Doesn't make that much of a difference, though, does it? Yeah, why not? I'll submit again. Let's just keep stacking on the constant factors until something finally works. But I'm not even gonna look at it. So what else can we do? We can do coordinate compression instead of this map thing. That's a possibility. What? Oh, wait. This doesn't need to be constant, does it? Because it's not actually... Oh my god. Okay, so, I don't need this. A, B, and then D dot kill. Oh wait, this would overflow. Actually, n is long, so it wouldn't. I would hate if this is the issue. How much trouble did you guys have squeezing this? Oh my. Okay. I did the exact same thing that I just complained about. What the hell? What am I doing? What is that? What did I just do to my own compiler? Try again. Why not? You had no TLEs? Wow, what a legend. Okay, if this what? How's that a problem? How am I getting a wrong answer now? ax times n plus ay. What's the problem here? Why is this dying? Oh, wait, this is a sample. I can test that. What does it think right now? This is problem div 1C, and I am completely dying right now. It is very saddening. What else would I need long for? I think the only thing that's the problem would be this thing. But n is long. Yeah, I probably have some weird n squared somehow. That could just be a possibility. So I've done a lot of things to optimize this. So n is long. How would that overflow? Oh wait, it wouldn't be overflow anyway. It's some other wrong answer. Yeah, this is like pure pain at this point. You know, I don't even need this. I can just, boom. Yeah, FS2 would suck too. FST is failing system test. What the hell? What is this now? Oh, 1, 2, 3. What is happening? Oh, 1, 2, 3. Yeah, 3 to 4 usually in div 1. Not this time, though. Definitely not this time. This time sucked. This was just like bash out the implementation. Yeah, I always brick on stream. It's like a rule. I can't not. It's why I don't record actual div 1 contests, because I just can't have that same level of focus. What is this? So this isn't even like relating these somehow. Zero, 2, 1, 3. Okay, to be fair, that auto could just be like random variation. It's not necessarily like faster. If you average it over 10 runs, it might be closer, for example. I just want to be done with this one. My god. This is so painful. Okay, right. So, something's wrong with this one. And it's this edge between 0 and 1, and... Wait, there should be 4 edges. What am I doing? There should be 4 edges. Oh. I have to, like, do the uniformity. Damn. That's annoying. Forgot about this. Persistent DSU? No, I just like clear everything. Like I just destroy the entire graph at the end of it. Oh wait. But that would work, right? Like there's no reason to ever I don't see any reason to try and reset things. I mean to for it to be persistent. I don't have persistent DSU anyway. Alright, how many attempts is this now? Are we still? We are still. Okay. Surprised so many people are still here, to be honest, because this has just been sad. Yeah, TLE again. Why are you guys still here? This has just been sad. It's like a constant struggle at this point. Okay, honestly, at this point, I'm just gonna look at the test and see if it's anything like special. If I can see them. I'm giving up on the attempts to try this. I don't think, I mean, it's not gonna help because it's a huge test. I just want to see what else is passed. So it like does totally, okay, so this is a problem. It's like even fewer groups is an even bigger problem. That's not useful. Alright, wait, I'm go to the bathroom again. I'll be back very soon. In the meantime, I'll think about this more. Okay, so yeah, there is a wait, what? Exit code -1? Oh, that's the checker, not that's the checker exit code because it TLEs. That's not my program. Like any other TLE submission will probably do that too. Although I can't even look at I can't even look at my own profile. Oh, I can. Okay, wait. If I can pull up some other TLE submission, it does the same thing because it's the checker that it's looking at. All right, so Yeah, okay. Well, I should entertain the possibility again that there's something that somehow makes this n squared, and then it's just a bug or something that I should look into. So let's try that, I suppose. Can look at this. Yeah, I mean, I'm surprised more people haven't tuned out by now. This is just sad at this point. Okay, so let's look at every section of the code again, and then I'm gonna feel stupid when I find this out. For each thing, put it into its group. For each edge, read in the edge. If it's the same, put it in the group adjacencies. Otherwise, put it in the other adjacencies. I don't actually even need this anymore. Pretty sure. Do I use this? I do use that, okay. Otherwise put in the other adjacencies. Now, put this in that map. Mem set everything to 0. For each, let's see. For each group, check if it's colorable. Yeah, it is relatable, that's true. Okay, for each group, check if it's colorable. Now, maybe this is the problem, checking if it's colorable. So for each thing, we want only the edges in... I don't think unordered map would do that much. It's kind of, that's true. Seeing me brick could be, like, inspirational somehow, in some convoluted sense. I guess that's possible. I'm gonna rename the stream. There. Perfect. So, let's see. For this is only inside its own group. So that's fine. Then for everything in the group, if it has not been visited, then run the DFS. Color is the vertices in the group. I don't actually know why I do that, because it's not that necessary. But, yeah, I don't know why I do that. It's not necessary, but I don't think that would be the problem. Not entirely sure. But, okay, so color groups I. Sure. Let's check this. So for each edge, if it hasn't been visited, then check the DFS. So this DFS is, if it's been visited, return. Otherwise, do the colors, do the components, check the possibilities. For each something, for each edge in the same group adjacent to this one. Although it actually doesn't matter if it's in the same group, I guess. If they have the same color, it's not possible. Otherwise, check that. And it's like O of M in total. Wouldn't it be? O of N plus M, I suppose. This DSU I've tested before, and it worked. So either the tests on that problem were weak, or it was... I guess it would be, but I don't know why, is the thing. Maybe this is the problem. Let's make this, yeah, it could be the set too. That could be a problem. Let me try making that not a set. That was what I was just thinking right now. Because, I don't know. So push back. Wait, what was div 1A? Would that have caused an issue? What the hell? What is this? Get P, right? Is that what I called it? No, that's not what I called it. Why do I? Oh, I don't have the bracket. Wait, was it div? Was that this div 1A or Why do you have a problem with pushback? Confused now. What is this scope issue? Oh wait, this should be P. 0. Zero. Awesome. Yep, div 1C from Codeforces round 680. As the title implies, I am not doing so hot. This is an amazing stream. I don't get what the why would that cause it to be? Oh wait. So if I is 0 or oh yeah, I forgot to start it. Whoops. Thanks. Damn. I'm doing so many things right now, and none of them are right. Okay. Yeah, this is on you can find this here if you want, which is the only reason why my viewership is so high, I'm pretty sure. Oh, come on. Alright, so it's probably not. Every time one of these optimizations fails, it rules out constant factor more and more. So this probably is some weird bug that does some stupid things that makes it impossible to do anything. But who knows? I don't. Alright, so for each thing, for each valid group, for each element in that group, like this would only be O of n, wouldn't it? This can't be the problem. Just use DSU for everything? I guess that can't hurt. Yeah, I don't see what the problem is. This is for each valid group. This is for each member of that group. So that means that in total, this visits each node at most once. And I don't use O-edge anywhere else, I don't think. It's just that specifically. Yeah, Nika is the real MVP. I don't even know if I'm saying that name right. There are some pronunciations that are interesting, but for sure. Yeah, I guess we can try DSU for everything. Let's see. how did I even do this? So, for int x groups I, for int y at gedge x. Yeah, that was definitely the MVP. If x is less than y. This is just because we're going to visit everything twice, so I only want to do it once. And these should be different colors. Temp. Did I paste the code as the input again? What? We get 2. Let's just try this one again. This is the other hard sample. Wait, so what would you say? You can use whatever happened in the DSU between the self edges and remove and insert the edges between each different pair. What do you mean by that? Oh, but you'd have to like... Yeah, wait. Okay, maybe this is the problem. I think this is the problem. And that I'm stupid and that I was recoloring it every time. Yeah, that is the problem. I see it. Okay, I know how to fix this then. Yeah, subcount is too big. It's like an inherent MLE, or it's like an inherent TLE from just allocating too much memory. It's possible, it's possible. Oh my god. Ah, this is stupid. Okay, I see how to fix this though. I just need to like... Okay, so actually using DSU here is bad. I would rather not use DSU here, because I want to preserve these colors. Yeah, I might have thrown something. Okay. Archive x equals color of x. So now what we're going to do is I'm going to initialize these like so. Wait, why did I even do this? I don't actually need to do this. I just realized that groups are disjoint. Why did I do that? I man, I'm not Not feeling it today, man. But yeah, why did I do that? That's just like stupid. Why did I do that? Yeah, my pain is like that I'm dumb and that I'm doing all these things to make it n squared for no reason. Oh my god. Okay, so this might make it wrong. What I need to do is... Like, these colors are already here. Like, I'm not changing these colors because these groups are just, Do I need archive? I don't think I do. Just need the colors, really. What's happening here, though? This should be fine, shouldn't it? 0, 2, x. Well, this is... The thing is that this is the... I didn't even realize that all of this, the thing I just removed, was making it n squared, and it didn't do anything. Yeah, that's true. I could take one of the old submissions. Let me try that. Put this in some saving thing. Like, it just could straight up be the case that this is the only thing that was causing the problem, and everything else was totally fine. And all of this constant factor optimization wasn't even necessary. Okay, but somehow this is wrong. I don't know why. Wait, what? Did it not compile? Why is it printing that still? What is it printing? Oh, wait, I just put this in the wrong file. Whoops. Yeah. Let's try it. Don't know what I've done, but maybe this fixes it. Wrong answer on test 10. Interesting. Okay, so what have I done here then? Because I'm not modifying the colors themselves with the DSU. Alright, I'll just save this one. Just look at this now. This is the army of the failed submissions I've accrued. So does it work with this? Wait, no, what I want is, does it work with this? Try adding this code and seeing if it fixes it. So if I take these out, then it fails. Oh wait, I see why, I think. I want to... What happens? Oh wait, yeah. Oh god, I forgot I was decrementing that. My god. Nika is actually my savior. I would be nowhere in this stream otherwise. Just persistence and having other a mix of persistence and having people in chat to carry you. That's what this was. To everyone who is here, thank you for either being here or helping. I should make someone VIP. I'm not sure if that's possible though. Only Twitch, I guess. Is there no VIP on YouTube? At least MVP, something. Alright, well, there's absolutely no way I'm doing the ABC now. So this is, yeah, this is gonna be it. For the purposes of the video, I'm going to go over the solutions to everything, but that will be it afterwards. Oh my god. Well, I'll keep the archive up for anyone who missed the stream. And you know, this is just gonna be it's gonna be painful for other people to watch, but I think I should leave it up. You said the persistence inspires people, right? So we can well, no, I can just put this at the end, and then in like the stream archive, it'll just timestamp it and stuff. So it'll should be fine. And then people could have the whole thing in one, but they only have to watch what they want. That's usually how the streams work. And plus, I just like, yeah, complete set after being carried by chat. That was the only reason, being carried by chat. Specifically being carried by Nika and Everrule, I think. Probably some others that were in there too. So many things. Alright, just for the purposes of the video archive, I'm going to do solutions. But if you've already seen the stream, there's not much else for you here, so you can tune out if you want. Yeah, I'm just going to do this for the purposes of completion. And because all of the stuff I was doing was like very scattered. So if you were just here for the solutions and not the other things, then this is the time. I'm definitely not doing ABC now. This was too much. This was too much already. Possibly later, maybe on a different stream. I'm not entirely sure, but definitely not now. Bruh, if I do ABC now, I'm gonna brick A. That's the state I'm in. I'm like actually gonna spend 20 minutes solving A. Okay, this is problem A. I don't want to brick A. I've done enough bricking today. So you're given two sorted. I'm doing solutions. You're given two sorted arrays. For example, 1, 2, 3, 4, and another sorted array of 1, 2. I'm going to strategically space these out. 1, 2, 3, and 4. So you want to find some ordering of the second array, so that every pair of elements, for example, the for example, the pair of the third elements, the pair of the fourth elements. Each of these pairs sums to less than or equal to a given number k, or a given number x, I guess. And the way to do this is, well, you just want to check if it's possible to reorder B. So consider like the maximum element. So if it's not possible to pair the maximum element with the minimum element, then it's not possible to pair this element at all, because there's no element, like, you want smaller sums. So if you pair it with something bigger and the minimum element doesn't work, then there's no way this other pairing is going to work. So you would first have to check if this is possible to pair with the minimum element. But then, at the same time, say you like have the minimum element, right? So if you were to pair it with something that's like smaller, then it would mean that it would be harder to make pairings in the future, because you have bigger elements that you have to pair with the bigger elements that you left in the array. So if it's possible to pair the minimum element with the maximum, then it's optimal to do so, and otherwise it's not possible. So at every step you want to pair the minimum with the maximum. And you can similarly pair the maximum in A with the minimum in B, either way. But what that means is you want say we're putting down these elements. So we put the maximum here, then we put the next maximum here, then we put the next maximum here, and so on until we're at the end. And basically this ordering is just the reverse of what B initially is. So you compare each element in B to the reversed element in, or you compare each element in A to the reversed element in B, and you check that, and that's the final ordering. And then just checking that is simple to see if it's possible or not. Now for B, this is div 2, by the way, relative to div 2. B is a fun one, and also confusing. Here's the statement, which took me longer to understand than to solve the problem. You have a contest. There are two contests. In one contest, you know the top, you know the scores of the top 100 participants. Actually, specifically, you know in the first contest, wait, I'm going to actually use a good color scheme. So the first contest is red, the second contest is blue. So you know, for anyone that got like a rank greater than or equal to 100, yeah, constraints are probably small just to be confusing. I don't see any other reason why they would be. Maybe to allow some sort of weird brute force thing or something, but it doesn't even make sense for that, so who knows. Oh yeah, the name, sure. Just do that right now. Wow, why is this going so slowly? You can spoil problems now, sure. Yeah. Alright. I have an idea. Perfect. Wait, I have a better idea, and then I can make the thumbnail my submission history. This is perfect. Alright, this is the best thumbnail ever. Okay, so back to this. Back to the statement. You have two contests. And in the first contest, you know the results of the top 100 participants. Specifically, you know on the first contest, I don't know what this diagram is, but it's what I'm doing. You know, in the first contest, these top 100 got a score of greater than or equal to A. And in the second contest, these 100 people got a score of greater than or equal to B. And then you know the same results for the third contest. That these people got a score of greater than or equal to C for the people that got greater than or equal to 100th place. And then these people on the first contest got a score of greater than or equal to D. Links don't work in chat, no, unfortunately. So we know the scores of these 100 participants are at least A plus B. And in the same manner, how do I draw with a mouse? Just like experience, some motor skills that I developed over the past while for no particular reason. I don't know. And then we know that these people have a score of at least C plus D. So we want to like make it so the top 100 people have the minimum possible score. So like minimize the score of the 100th person overall in terms of like the sum of the two contests. So we know these people have a score of at least A plus B. We know these people have a score of at least C plus D. Because we want to minimize it, we might as well make it so these people have a score of exactly A plus B, and then a score of exactly C plus D. And we know that we have 100 of each of these. I'm not streaming Among Us. That's a bit of a lot. So we know we have at least 100 people with this, and we know we have at least 100 people with this. And there's no reason to increase these because like we want to minimize it. So the essential idea is the top 100 is going to be either this group or this group depending on which has the higher score. And so it just like we just need to know which is the higher score, meaning that the answer is the maximum of the possible scores of the two groups. Okay, for C, you have two numbers. Let's call them P and Q. You want to find some number x such that P is divisible by x, or we'll use this notation x divides P, but x is not divisible by Q. So Q does not divide x. Okay, so first, we have to use the theory that each number can be broken into a bunch of prime factors. For example, let's take Q equals 60. Then it's like a product of a bunch of prime powers, kind of. Which is to say, this is 2 squared, 4, times 3 to the 1, 3, times 5 to the 1, 5, which is in total 60. And it's just like a bunch of primes. So now let's consider P. For P, let's consider P. If P is not divisible by Q, then P just works as X, because and we want to maximize X. So P is divisible by P, obviously, and P is not divisible by Q, and you can't have a number divisible by a number that's bigger than it, so P is the largest possible number. So if it's possible, we want to use P. Otherwise, P is divisible by Q, so Q divides P. And then what that means is the prime factorization of P has some numbers, for example, 2 to the x times 3 to the y times 5 to the z times some other number k, which is the rest of the primes. We'll just kind of ignore this. So if this is divisible, we have these series of constraints. 2 to the x must be divisible by 2 to the 2, which means x is greater than or equal to 2. 3 to the y must be divisible by 3 to the 1, which means that y is greater than or equal to 1. And 5 to the z must be divisible by 5 to the 1, So z is greater than or equal to 1. And this is going to be true for all of the prime factors in Q. So for us to, and k doesn't matter. K we can just like totally ignore and bring back in at the end. But the idea is we want to make it so we want to break one of these conditions. And if we break more than one, then it's going to give us a lower number than if we break one. So it's like not that big a deal. So I mean, we don't want to break more than one. We want to break exactly one of these conditions because breaking a condition means reducing the number. So let's try all of them. Let's try breaking the condition so that x is less than 2, which would mean we want the highest possible x, so let's make it so x equals 1. Right? And then this is just the number of times we need to subtract x, like to divide by 2 to make x equal to 1 is just x minus 1. And we can also try making y 0. So this will just cost y minus 0 because we have to divide by 3 that many times. Once we can try making z 0, so this is just z minus 0. And then to make this happen, we get the number p divided by 2 to the x minus 1. For this, we get the number p divided by 2 to the y. And for this, we get the number p divided by 2 to the z. And wait, this is not 2. This is 3 to the y. And this is p divided by 5 to the z. And of course, this is an integer because we already know that 3 to the y is divisible by p. That's like part of it. That's kind of by definition. So essentially all we have to do now is for each prime factor, we just take the maximum value over all of these. Because this is both going to be divisible by p because we just divided something by p. And then at the same time, it's not going to be divisible by q because we just made it so. So over all prime factors, you essentially you find the minimum of p to the for all primes, like for example k, you want to find the minimum of k to like the power with respect to p minus the power with respect to q plus 1, which is essentially like, for example, x minus 2 plus 1. And then take the minimum over all that. And factorization is a standard thing. You can do it in like root n or something. Yeah, I don't think there's an O of 1 solution. I'm not exactly sure. And if there was, I wouldn't be able to find it because I'm not good at math. Also, if you want to do Among Us on my server, you can just like make a channel, whatever you want. Yeah, sure, I can explain the code. Where would that be? No, not that one. This is where I was in the virtual, at least. So the basic idea is, first you generate the primes. And to do that, you just do like a sieve of Eratosthenes. It's like a well-known thing. And then you just make a list of all of the primes that you found with the sieve. Just put them all in a big list. And then this is the function for finding prime factors. First, sanity check, then make a vector of them. And essentially you try all of the prime factors and see the divisibility, and then you can like get the prime powers and stuff. Except there's a special trick. Note that for any two numbers a times b where they're less than or equal to n, then the minimum of the two is less than or equal to square root n. Because otherwise, you would have two numbers that are greater than square root n being multiplied. Oh, my Discord is in the description. You can find that. In fact, I recommend joining the Discord because it's in the description, and it'll help you find the streams and stuff, if you know what I'm saying. It's a good idea. But the fact is, the minimum of these two is less than or equal to root n. Because if you have two numbers that are bigger than root n, then they're going to multiply to greater than n. So that's just like it's just the truth, right? So that means that we only have to try the primes that are less than or equal to root n. Because either we'll be left with some number x, where x is greater than root n, but there's only one x. So if we tried all the primes less than or equal to root n, and then we found nothing, then we know that like x is the last remaining prime. So that's the idea behind the square root thing. You try all the primes less than or equal to root n, and then rule all those out, and then if you have some other prime, then it's going to be greater than root n, and you can just take it, because like you just know it's a prime. Because otherwise it would be composite, and then there would be some more things that would be eliminated in this stage. So that's how you would do it in square root n. And in fact, it's even lower than that because of the complexity of the prime gap, but I'm not going to worry about that. That's the idea. And my template can be found on my profile in the submissions and stuff. So yeah. All right, problem D. What an amazing problem. Don't you guys love this one? Anyone a fan of it? I know I'm not. You're given an array. Consider splitting this array into two subsequences. For example, we're going to say these elements are blue and the other elements are green. Then sort the blue sequence in increasing order and sort the green sequence in like decreasing order, or non-increasing and non-decreasing. Then the answer for this subsequence is the absolute difference between each element. So the absolute difference between these two is 4, this is 1, this is 4. And then the answer for this is the sum of all these. You want to find the sum of these answers over all possible subsequences. So the idea is, I don't need to get rid of everything. So first observation is that you can sort the array because the final values in the subsequence don't depend on the initial order, which means you can make this initial order anything you want, since you're going to try all the subsequences anyway. Okay, now the idea is, this is a technique called contribution to the sum. Let's find out what 2 is going to do to the answer. Like what this element is going to do in the answer. And the problem we have here is the absolute value condition. So we have some sort of piecewise thing. Like if xi is greater than yi, then you return xi minus yi. Otherwise, xi is less than yi, so then you return yi minus xi. That's sort of the absolute value kind of thing. And this is a problem because it means it's kind of hard to get rid of. But you would want to get rid of it because then you could, if there was no absolute value, then you can just, for example, you could sum up all the negative yi's and all the xi's and then combine them in the end. But the absolute value is the problem. How can we get rid of that? One thing we can do is explicitly say that this 2 is going to be the lesser element. So then we guarantee that whatever y we pick, yeah, it's been a long stream. I've been on C for a long time. We guarantee that, say we pick some other element. We guarantee that the other element is going to be greater than whatever the blue one is. I'm gonna make this blue actually. So now, if we guarantee that this is lesser, all we need to do is sum up the amount of times this is included. which is to say we sum up the value of negative xi over all times that we include this value. So now we've reduced the problem to how many possible ways are there for this value to be the lesser element. Let's just say it's in A, because, like, why not? Let's say it's in sequence A, or sequence P, I guess that's what they called it. Let's say this is in sequence P. Then we have, let's say, let's consider this. So we have A elements on the left, and we have B elements on the right. Then let's fix that we take, for example, X elements into P, which means that this in sequence P is position X plus 1. So we know that, like, B, the sequence Q is going to go this way. That is, the last element is going to actually be the first element because this array is sorted. So we want that the X plus 1th element of the Q sequence is, running out of colors. The X plus 1th element of the Q sequence is in this range. So say we take X elements of X elements into P here, and then Y elements into Q here, then we have the condition that X plus 1 is less than or equal to Y. Okay. Now the thing is, this would be hard on its own, but Y is actually dependent on X. Because the number of elements we take in Q on this side is just the number of elements we don't take in P. Which means that we will take, on this side, it would be A minus P, or A minus X, into the Q sequence. And that means because this is in the P sequence, everything here, like the rest of the Q's are going to be here. Which means that we have n over 2, because we need n over 2 elements in the Q sequence, minus A minus X is equal to Y. This is the number of elements we have in B on this side. So let's replace the Y in this with this. Is less than or equal to n over 2 minus A plus X, doing math to expand this out. But wow, look at this. The X's cancel. So we actually have 1 is less than or equal to n over 2 minus A. Which is to say, A is less than or equal to n over 2 minus 1. So this is like mind-blowing, isn't it? Us being able to make this a lesser element is independent of how many things we take on this side. In fact, it's independent of what we do at all. All that matters is that this size, the number of elements we have on the left, is less than or equal to n over 2 minus 1, which just means that this element is on the left half of the array. Okay, why? Why? Because let's say you take X elements here, and then say you decide that you're going to take X plus 1 elements instead, which means that you gain an element in A. But what that means is that you lose an element in B here, since that spot is now filled with an A. So the corresponding effect is that you gain an element in B here. So when you gain an element in A on this side, which means that X increases, you also gain an element in B, which means that Y increases. So they're the same. X doesn't matter. And similarly, if you reduce it, it also reduces. So X doesn't matter. The only thing that matters is that this position is on the left side of the array. It's the same exact idea as for the greater, like for it to be the greater element. So essentially, consider its position. Consider this array, and then we have something at position I. If I is less than or equal to n over 2, this is 1 indexed, then we want to sum up the negative of ai. Otherwise, I is greater than n over 2, so it's on the right half, so we want to sum up the positive ai. Okay, now in terms of the contribution to the sum, we want to figure out how many ways that we'll get negative ai and or positive ai. And we fixed that this is in the first sequence. So for it to be in the first sequence and be negative, like remember that nothing we do with this matters. The only thing that matters is this position, which means that we have by the way, I'm using the n as the big N, as in like the length of the sequence itself, not the input value n, which could be confusing and probably is actually. But here we have this orange. These like orange things are n minus 1 elements, everything except for this, and we have n over 2 elements that we want to pick for the B sequence, for example. And we have n over 2 minus 1 for the A sequence. So this is just the binomial coefficient. n minus 1 choose n over 2. We have n minus 1 places to put n over 2 objects. I am 17. And like that's it. So regardless of position, we sum up negative ai or ai depending on the position this many times. And the final part is that we have both A sequences and B sequences. So it's the same regardless of whether this is in A or if it's in B. But what it means is that we have to multiply by 2 at the end because like there's symmetry here. Both A and B are possible and they're both counted. So the final answer is 2, because of the symmetry, times n minus 1, choose n over 2, times these things, the contributions, which is to say the sum from I equals n over 2 plus 1 to n of ai minus the first half. So this is the second half, and then we subtract the first half, which is to say the sum from I equals 1 to n over 2 of ai. And this is the answer. This all comes from contribution to the sum and trying to find out when this is the lesser element or the greater element. But this is the final answer. And all of this can be computed in modulo relatively quickly, just O of n. Okay, that's problem D. Now we'll finish off with problem E, and then conclude the stream, ideally. Alright. In problem E, you're given a graph. I'm scared to draw this. You're given a graph, and you have this graph here. Clear my head for a second. Okay, you have this graph. This is the input graph, I think. Yeah, and then these have labels of 1. Actually, what matters is that these have group numbers. So each of these nodes have their own group. 2, 2, and 3, and 3. And with this graph, you want to do some stuff to it. Specifically, you want to find how many pairs of groups, for example, the pair of groups 1 and 3, exist, so that when you consider the combination of their graphs, for example, this like the subgraph that only contains nodes from 1 and 3. When you consider that graph, you want to find the number of pairs such that that graph is bipartite, which means that you can split it into two subsets such that there are no edges between any two nodes in the same subset. For example, this graph could be this. You would have these two nodes from group 1 and these two nodes from group 3. This is a possibility. And you can see here that on these two sides, there are no edges between any two nodes on the same side. So the graph is bipartite. Wait, how did I fix this? I don't think it requires DSU, actually. It's simpler than that. You just have to like not be dumb. Wait, let me remember what I did to fix this. What was the difference here? No, it wasn't DSU, it was something else. I'm confused now on why this was broken. And I should figure out why this is broken before I try and explain the solution. Don't actually remember what I fixed. That's interesting. Yeah, I know I copied. Well, this was the most recent code. I restored that. I don't know why that broke. I know commenting this out was the issue. Wait, let me look at something. Why was this wrong? Yeah, I haven't even looked at div1d. I don't want to because I'm terrified, given that how C was. Like, just look at this. So, okay, I really should make sure that something isn't wrong here. What did I do to fix it? I know how TLE was fixed, but... Oh, right, yeah, right. It was this decrement that was the problem. Right, okay. I don't know how that passed 9 tests. It's, like, weird. Yeah, okay. Okay, so, disregard that then. That was just the stupid thing. So how do you count these pairs? First, it was that... Okay. So consider like a group like this. Like, for example, all of these nodes are in the same group. This is already not bipartite. The condition for bipartiteness is that if a graph has an odd cycle, then it's not bipartite. And if a graph is bipartite, you can give it two colors so that any two nodes who have the same color or any two nodes that are adjacent have different colors. Because that's just the way to assign them into the sets. Yeah, this is not bipartite. But that's just the number of ways to assign them, or that's just the way to assign them into the two sets such that they don't have, like, problems. Right, because if two nodes are in the same set and they have the same color, then that's the same as, like, there being an edge between two nodes in the same set. And so that's not bipartite. And this idea of bipartite coloring is going to be important. So first, if we have some group that's like already not bipartite, then adding edges to it isn't going to help. Because that just makes it harder. Bipartiteness is defined by there not being edges that have a certain property. So if we have more edges, the edges that had that property are still going to have that property. Right? So what that means is we can ignore all the groups that are already non-bipartite. So the first step is checking each group and seeing if it forms a bipartite subgraph by itself. And then now we assume we're looking at only those. Now, consider two groups that are like totally non-adjacent to each other at all. right? For example, say we have group 5 here and group 6 here. Now, we already have the property that they're both bipartite, because otherwise they would be part of this. So if they're both bipartite, and we don't have any new edges between them, then like they're still both bipartite. So it doesn't change anything to have these like groups be united. Which means that the only groups we actually end up caring about are the groups that have an edge between each other. And this is good. There are only O of M edges, which means that we only have O of M pairs of groups to check. Cool. Now it remains to check. Now we can turn this problem into counting the complement, counting the number of groups that like aren't bipartite, and then we can subtract that from the total number of pairs in total, because the rest of them by default would be bipartite. And specifically, there are G groups that aren't part of this. Then there are G times G minus 1 over 2 divided by 2 possible groups, or possible pairs. And then we subtract the answer from that. This is just n choose 2, standard thing. No, I'm explaining this now. I'm doing the solution, finally. I have eventually solved it with the help and the carriage of my chat. So, yeah. Alright, so now we have to find, so now for each like pair of groups, we want to essentially find out if adding the edges between the two groups makes it non-bipartite. So let's just consider all the components in the two groups individually. For example, say we have this component and this component just chilling here, and on this other side we have this group. For example, something like this, I don't know. And then we add in these new edges with this. For example. Now, the property of a bipartite graph is that it can be colored. So let's find the color. Let's find any coloring of all of these like individual components. And in fact, the important part is that we do this beforehand, because groups are independent of each other initially, so we can find their color at the beginning and then not have to be an idiot like me and recolor them every time. Yeah, don't do that. So we say these colors exist. So now every edge, like consider this edge. This edge is between two nodes with a different color, which means that for this to work, what we would have to do is we would have to invert all of these colors. And then yeah, we would essentially have to invert all of these colors. But like, let's just like not do that. Instead, we'll just say that these components are kind of fixed, and that we'll say that if all the edges from one component to another have the same relation, like for example, in this, the two colors for both of these edges are both equal, so that means it's fine. So we have the condition that these like colors of these two components must be the same, instead of that they're different. So we'll say these are 0 if they have to be the same. But now we have like a different problem here. We say that this is 1 and this is 1, so these must be the same. But at the same time, we have 2 to 1 here, so these must be different, and that's not possible, because we have a contradiction. So it's only possible if we don't have a contradiction. So the idea is we group all these components like into nodes themselves. for example here, and then now we say that these edges are between the components instead of the individual nodes. So let's consider this new graph where we do that. And we have two edges. Both of them say 0, which means both of them say these two colors must be the same. And we have this edge, which says that this must be the same, and we have this edge, which says they must be different, which is not possible. And in general, the way to check that this is possible is a different kind of like bipartite coloring algorithm. Because like we can do greedy kind of. We can just like say this is a color. Then for all of the other adjacent nodes, we know their color already. They have to be the same as this one. So if this doesn't work out, this sort of greedy thing where we fix the colors based on previous ones, then there's no way to do it because it has to have that color. This only works with bipartiteness when there's exactly one other color that works. But in this case, it does work. And say we arbitrarily assign this to have color 0 or color 1. Then we say that this must be the same, which means it has 0. And it has to be 0. So because we have this other condition that says they must be different, it's not possible. Because this has to be the same as this, and it has to be different. So the way to do this is either you can do some sort of bipartite DSU thing, which is a fun implementation that I will leave as an exercise, or like basically as you merge components, you only recolor the smaller ones. And it's actually not terrible. That would be, for example, small to large DSU. You can do other things like union by rank, or there are a lot of possible ways, but I highly recommend union by size for this, or at least that's the most intuitive for me. So then, the final step is you can do DSU, or you can just build this component graph, ignore all the nodes that aren't affected by these edges, because otherwise you would have some sort of O of n squared thing, and then you solve on these nodes specifically only. And you try and do the coloring algorithm and see if it works. And if not, then you have a contradiction, so you add 1 to this because it's a pair of groups that don't work. Implementation for this is very fun. You can check out my code if you want. I will link my submissions in the description in the VOD. But there is a lot of stuff here. I did kind of like both DSU and the initial coloring at the same time. And also you want this like coloring to be done in the beginning, because otherwise if you do it over and over again, it could also be O of n squared, as I learned the hard way. Okay, that's about it. That is E. I have nothing more for you. I want to be done with the stream. This has been going on too long. So, yeah, I think that's good. This was Codeforces around 680. Maybe I'll do some sort of ARC thing later. And I think tomorrow I'm going to stream this round also at a different time, perhaps. I'll figure that out. If you want to know what I'm doing, you should join the Discord, which is in the description, because it's like in the description. You can do it if you want, and you can join the Discord. I'm saying that over and over again to like repetition, because the more you say things, the more people will do it probably. So join the Discord. It's in the description, I think. It's like right here. Yeah, you can click on that. Okay, that's all I got. I hope you enjoyed. I'll figure out what to do with the ABC. I'm not really sure right now. To be honest, I can't really think right now. Is brute force and greedy the same thing? Not exactly. I mean, I don't think so. Brute force is like exhaustive, and greedy does the best possible thing. So it's like kind of different. Yeah. Okay. Alright, goodbye.